Here's an interesting and deceptive question involving the use of Pythagoras to find unknown sides for a square inside a square at an angle. It's tricky because you literally need to think outside the box, that is the inside square. In order to find the values of the pronumerals, let's start with x, we need to look at this triangle, recognizing that that is a right angle in the corner, and therefore x is the square root of the hypotenuse squared minus the square of the shorter side, and that gives 12. Once we've found x, w is the difference between 28 and x, which gives 16. One of the reasons why it's a tricky question is because the diagram is not drawn to scale, and the box appears to be symmetrical left to right, but in fact it isn't. The box does need to be slanted. When I first looked at this question, I was thinking of the properties of a rhombus, in this case a square, which is a special case of a rhombus. And a rhombus has diagonals that bisect each other at right angles. And so I was looking at the symmetry of the question and got myself quite confused. When I first tried to solve it, I was looking at the triangle inside the inner box, and that was misleading me. So when I realized that I needed to work outside the box, it all made sense. I decided to draw a picture in GeoGebra to show that the square on the inside has to be slanted. It's the only way this will work. Alright, so to find z, we apply the fact that the hypotenuse of the next triangle along is 20. We know that w is 16, and that will give z equals 12 as before, same as x. And then of course y must also be 16 by applying the symmetry of the diagram. Interesting question, very misleading because of the way the diagram was drawn. Looked like there was symmetry when in fact there isn't.